Hello everyone, I'm very sorry to interrupt your Easter break, but something was brought to my attention by Natalie number one, who has really pointed out something that I got confused with, I think, when I was teaching you, and generally I've been quite confused with for a while, so I've had to be thinking about it a lot today, and I made this video to help explain to you what's going on. So you're seeing a transformation of a trig graph appearing on the screen. I'm going to tell you that that is y equals cos ax plus b, and your job is to find a and to find b. Now, here is cos of x, the original graph. So the first thing you can do is find out what a is by considering like a gap between the x-intercepts, and you can deduce that we're squashing up the wave to create like more waves in the same space. So a is equal to 3. And now if you sketched y equals cos 3x, which is what I taught you, turns out it's the wrong thing to have taught you, you will get something that looks a lot like this. And it kind of goes through at 30 because we squashed that 90 intercept up to 30, and the 270 we have divided by 3 to get 90. So that's exactly what the graph y equals cos 3x looks like, and that's true. Now from here I'd be expecting people to come up with b equals minus 10 because we're shifting the blue graph 10 to the right to get the red graph. That's not true. That's just incorrect. It's just completely wrong. So I wanted to correct myself. Now, what I want you to do when you do one of these questions is to consider the x-intercepts and putting the coordinates into the equation that you are given. You've already found out that a is equal to 3, and you know that x is 40, so putting 40 into that equation, and y is going to be 0 because we're on the x-axis. Now, if we go on and solve that equation, using cos to the minus 1 and a cast diagram, we're going to get that 120 plus b equals 90, 270, and so on. Now, here, if we pause the video for a second, the green dots that you see on the original cos graph and the one that you see on the graph given to you in the question, that's where the x-intercept that I want is. So those two green dots are the two things. Now, in my working, that comes out as the 90-degree answer. 270 is actually the dot at 270, and that is not the x-intercept that I'm putting into my equation, where I've got an x value of 40. You can see because the gradient is negative going into that, but the gradient is positive going to the 270. The one that I want is the one at 90 degrees, and it's going down, just like the one in my graph that I'm given to you. So we'll pick up from there. And so the 90-degree one is the one we want. From that, we find b is equal to 30, not, after all, equal to minus 30. And so this is the correct equation for the graph. Okay, let's look at another one now. So I'm going to give us a tan graph, I think this time, only it's going to be stretched out. It's going through 30 on the x-intercept, and there we go, there's the tan graph shape, and it goes back the other way. I'm going to put the asymptote on, and this is going to be the first thing that's going to help us. So I'm going to put 300 on the x-axis there. And if I think about going backwards, I think minus 240 will be the asymptote at the other side of this wave. Now, y is equal to tan ax plus b. And the first thing I'm going to do is draw a sketch of my original tan graph and think about what the stretch is going on here. It is going from 90 to 270, so I'm stretching it out and making it bigger. So a is equal to a third because the stretch is a scale factor of 3, so it's 1 over that. So Ordinarily, we would draw out the graph of y equals tan a third of x. This is the wrong approach. This is the thing that I taught you to do that's just wrong. And then I'd be getting you to think about moving that blue graph so it lands on top of the red graph. And that's just not going to work. So no, b is not minus 30 at all. It does not work. So instead, what we're going to choose is to put in a third where a is into our equation. We're going to locate the x-intercept on the graph that we are given, and that gives us x is 30. Now a third of 30 is 10, so we just have to solve the equation in green. And these numbers, 0, 180, they come from the x-intercepts of the original graph. The one that we're going to take is the one that goes through the origin. It gives us a b value, not of minus 30, but of minus 10. And there we're done. We found a and b, and that's the end of the question. Okay, so I can almost hear the eye rolling through the video. I know that you'll want to know why this is the case, and it's something very specific to doing the graph transformation of f of ax plus b. Now, you're used to the idea of doing the inverse thing using a and using b. Because you're doing the inverse operation, i.e. what you're doing is you're dividing by a, and you are subtracting b from the x-coordinates of the original graph. Because you're doing the inverse operations to those x-coordinates, you're actually doing them in the inverse order. So whereas you follow BIDMAS usually, you're reversing BIDMAS, so you're working backwards. In fact, it's equation solving without you realizing that it is equation solving. So for the standard y equals f of ax plus b, the first thing you would be doing is a transformation, a translation, that should read. Let's correct that. Translation to the left by b units, and then a stretch away from the y-axis by a scale factor of 1 over a. So it does go in that order. I'll try and explain why in a second. So if we go back to that first example, we start with the equation and we try to sketch it. So if we do y equals cos of 3x minus 30, and we're going to sketch this from scratch. It should explain it. So we're going to start with y equals cos x. Then we're going to think about how we do y equals cos x minus 30. So you can see I'm doing that translation of 30 to the right first. Now I trust you all to be smart enough to know that this is the cos graph moved by 30 to the right. I'm going to take the x-intercepts and I'm going to add 30 to each of them, so I get 120 and 300, I think. So this is our starting point, and I want you to think of this graph as y equals f of x. Now that is also, f of x is what cos of x minus 30 is. What happens when I make that f of 3x? What does that look like as a function? And this really is key. I'm going to change x to 3x, and all of a sudden I've got that function that I want. So this is why it makes sense to do it this way round. And this is why I'm now happy that I understand the subject much better than before Natalie's intervention. Thank you again, Natalie. So now I do my squishing up of the wave just by dividing 120 and 300. by the number 3, and it gives me the original question. So I'm back to where I started from. It worked. I'm really happy. Go us. Okay, so to summarize how you're going to do these in practice is you're going to find A by using the original sketch. So whatever the sketch is, you're going to kind of find 2 points, find the distance between them, and figure out the scale factor and find A from that. Once you've done that, you're going to use A. You're going to look for an x-intercept in the graph that you are given. So you know that y is equal to 0 at that point because it's an x-intercept. You've got the value of x itself, and you've got the value of A. You can then go on and solve the equation to find the value of B. That's the key. That's what you're going to be doing, equation solving to find your value of B. So you get x from the graph, it's the x-intercept. You get A that you've just already found, and then you solve to find B. And here's a final example. Okay, so the final example, I'm going to give you another graph. This time it's going to be a sine wave, well, a sine transformation. 30 and 75. We'll go ahead and put 120 down as well. So y equals sine ax plus b. And we're going to find A and B. Now, as ever, we start with that original graph. We need to find out what A is. The gap there is 180 between x-intercepts. On the graph we're given, it's 45. So I can see I'm contracting it up by a scale factor of 1/4, and that means A is equal to 4. So originally you would sketch y equals sine 4x, and it looks really similar. It's a similar shaped curve, like the shape is now perfectly the same. We would just need to shift it left or right. But again, this is not the right approach. It would give you this inkling that you would need to add 15, but b is not 15. It doesn't work like that. We have got a is equal to 4. We're going to substitute that into our formula that we were given, where a is. And we are going to look at the x-intercept at 30. We're going to change y to 0. X turns into 30, so that's going to give us 120 plus b. Now here, we're going to write down a few of the x-intercepts when we solve that equation, and we get 0, 180, and 360. All of those are visible on the original graph. So we're going to color code these. 180 is the yellow one, and that turns into a b value of 60. The blue one is 0, that turns into a b value of minus 120. And the red one is 360, that turns into a b value of 240. So which one do we take? We could take any of those really, or could we? It is important you look at the x-intercept that we've just found and notice that the graph is going from top to bottom there, so it's a negative gradient. And which one of these works? Which one of those has been moved to be this x-intercept? Well, the blue one has a positive gradient. It's going from below the line to above the line as we move from left to right. So it can't be that one. And that's true of the red one as well. In fact, it's the orange one. You can see it has a downward shape, and that's why we only want the yellow one. So we're going to use b is equal to 60. If we used either of the other two, actually it would be that red line reflected in the x-axis would be the graph that we were after, and that's not the one we're given. So it is the orange one, and b, as a result, is going to be equal to 60. So let's have a look about working backwards from this. Y is equal to sine 4x plus 60. Well, we're going to be doing y is equal to sine x plus 60. Here's the graph of that. So we're moving everything to the left by 60. It's quite straightforward. We just subtract 60 from all of our known intercepts. So that's the graph. And we're thinking this is f of x. This is y equals f of x. So f of x is equal to sine of x plus 60. And now to create the graph that we want f of 4x. And if we do that, f of 4x, you can see I'm replacing x with 4x, and it gives me sine 4x plus 60. So now I divide everything by 4. And I can see it starting to work, so I'm going to draw a happy face. And I divide all of those intercepts by 4, and I get that original graph that I was given at the beginning of the previous question. So it's like I've worked backwards to getting that, and it works doing it that way. So if you have to sketch, you can do it like this, but you have to reverse the idea of the operations. Thanks for listening, guys. It was me misleading you, and if any of you got confused by this, I really do apologize. But I'm quite happy because I've learned something new. So thanks for the third time, Natalie. I won't thank you again, but that's the third thanks. Thank you so much. That's really helpful.